Hello students, so we are doing inverse trigonometric functions. So today we will be learning about the properties of inverse trigonometric functions. So based on these properties you will be solving questions. So first property, we have seen that sine inverse of x is x if this x belongs to closed interval -1 to 1, right? So based on that we have to write other properties. So first property is sine inverse of 1 upon x is cosec inverse of x, where x is greater than or equal to 1 or x is less than or equal to -1. So this is based on the domain 1 to -1. So how to prove this? Now we have to put this cosec inverse of x equal to some y. So our x is cosec of y. Now cosec of y means this is your 1 upon sine of y, because cosec is 1 upon sine y. So we can write sine y here and x here, that is we are multiplying like this. So sine y is equal to 1 upon x. So your y is sine inverse of 1 upon x. So we have proved this to be equal to this. We started from our RHS and we proved it to be equal to our LHS. Let's write second property. Cos inverse of x 1 upon x is equal to sec inverse of x. X is greater than or equal to 1 or x is less than or equal to -1. So same way you have to prove this also, that is you have to take sec inverse of x equal to some y. So we can write x equal to sec of y. Sec of y you can write 1 upon cos of y. Then multiplying this you will get cos of y equal to 1 upon x. So y is cos inverse of 1 by x. Then third property, is for tan inverse. So tan inverse of 1 by x is equal to cot inverse of x, where x is greater than 0. So same way you have to prove. Now let's move on to another set of properties which we have already learned. We'll do the proof today. So first one is sine inverse of minus x is equal to minus sine inverse of x, where x belongs to closed interval -1 to 1. So start with our LHS. Let sine inverse of minus x is equal to y. So we can write minus x equal to sine of y. So that x is equal to minus sine of y. So we know that minus of sine theta is sine of minus theta. From our trigonometric functions we have already known that. So sine of minus y. So this is minus x is equal to sine of minus y. Now sine inverse of minus x we have taken y, right? So x is our sine of minus y. So sine inverse of x, taking sine inverse both the sides, you will get sine inverse of sine of minus y. So this will be minus y, okay, which is nothing but our sine inverse of minus x. So minus sine inverse of minus x. Okay, this is sine inverse of x. Okay. So sine inverse, this minus you can take this side. So you will get the required result, that is sine inverse of minus x is equal to minus sine inverse of x. Okay, that is this result. So you have to start from your LHS, okay, taking this to be equal to y, taking sine that side, x is equal to minus sine y, then x is sine of minus y. Okay, then taking sine inverse both the sides, you will get this result minus y. Then this y you have to again substitute as sine inverse of minus x. Okay, then second property I'll just write. This I have written already, so I'll not write, in that another video. Then also we have cos inverse of minus x, which we have written pi minus cos inverse of x. Okay, here x belongs to minus 1 to 1. So let's prove this. So taking cos inverse of minus x to be equal to y, so this you can write minus x equal to cos of y. Okay, then x is our minus cos of y. Now we know that cos we can write minus negative of this will be pi minus theta, right? So cos of pi minus y. Okay, now taking cos inverse both the sides, so cos inverse of x equal to cos inverse cos of pi minus y. Okay, so you'll get cos inverse of x equal to pi minus y, and y is our cos inverse of x, so pi minus cos inverse of minus x. So this is the required result. Okay, same way it is for sec inverse and for cot inverse. Next property, fourth one. Okay, first one, sin inverse of x plus cos inverse of x is equal to pi by 2. Okay, where x belongs to minus 1 to 1. Now you have to first take let sin inverse of x be equal to y. So from this your x is sine of y. Okay, now sine can be written as some pi by 2 minus cos of pi by 2 minus y, right? This is from trigonometry. Okay, now taking cos this side, you will get cos inverse of x is equal to pi by 2 minus y. Okay, and y we know it is sine inverse, so pi by 2 minus sine inverse of x. Now sine inverse you have to shift this side, so it will be cos inverse of x plus sine inverse of x equal to pi by 2. This is our required property. Okay, second property, tan inverse plus cot inverse of x is equal to pi by 2, where x belongs to r. Okay, so this also we can prove same way. Okay, so tan inverse you can take it as some y, Then the tan you can write it as cot pi by 2 minus y. Okay, same way you have to prove. Then third property, cosec inverse plus sec inverse of x equal to pi by 2, where mod of x is greater than or equal to 1. Okay, next set of properties, these properties are actually same as the properties, the trigonometric identities we have learnt in our 11th standard. Okay, tan inverse of x plus tan inverse of y is equal to tan inverse x plus y upon 1 minus xy, okay, where xy is less than 1. Okay. So for this you have to take tan inverse of x to be equal to theta. Okay. So and this tan inverse of y to be equal to some another angle, say phi. Okay. So from this x is our tan theta and y is our tan phi. Okay. Now using trigonometric identity, that is tan of theta plus phi, tan of a plus b, tan of a plus tan of b upon 1 minus tan theta into tan phi. Now you have to substitute value of tan theta and tan phi, that is tan theta is x plus y upon 1 minus x into y. Okay. Now this tan you can take this side, so you will get tan inverse of this, and theta plus phi is our tan inverse of x plus tan inverse of y. Okay. Same way you can prove the other two properties. So I'll just write second property, tan inverse of x minus tan inverse of y is equal to tan inverse x minus y upon 1 plus xy, where xy is greater than minus 1. Third property is 2 tan inverse of x is equal to tan inverse of 2x upon 1 minus x square. Okay, mod of x is less than 1. Then there is one more set of properties. Okay, we'll just quickly go through it. So first one is 2 tan inverse of x is equal to sine inverse 2x upon 1 plus x square. Okay, let's prove this. So start with tan inverse. Let tan inverse of x be some y. Okay, so we can write x to be equal to tan of y. And taking the other side, that is sine inverse of this. So take sine inverse of 2x upon plus 1 plus x square equal to sine inverse. Now we have taken x to be tan of y, right? So you can substitute here in place of x. This is your RHS, right? So 2 into tan y upon 1 plus tan square y. Okay. Now if you know the trigonometric identity of previous year, then this whole thing is our sine of 2y. Okay, so using the property sine inverse of sine of x, you will get here 2y and y we have taken tan inverse. So this is tan inverse of x. Okay, this is our LHS. So same way you can prove other two properties also. I'll write the other two properties. Second, 2 tan inverse of x is equal to cos inverse 1 minus x square upon 1 plus x square, where x is greater than or equal to 0. Okay, for this you have to make use of cos in terms of tan. Okay, then 2 tan inverse of x equal to tan inverse 2x upon 1 minus x square, minus 1 less than x less than 1. Okay, here you have to make use of tan, property of tan, that is trigonometric identity related to tan. Okay, so these are the properties.